The last example, I'm giving you some zeros, and I want to know what was the original polynomial that created these zeros. 0, 4, and 1 plus I squared root of 2. Now, before we jump anywhere, I see that I square root of 2, and one of the rules with our imaginary solutions is that they come in conjugate pairs. So right off the bat, I know that 1 minus I square root of 2 is also a 0. I've got to make sure I include that. So when I see that, I see 4 different zeros right here. 1, 2, 3, 4. Which means this is going to be an x to the 4th when I'm done with it. So now that I've got these zeros, I need to convert them to factors so that I can FOIL everything out and do all my algebra. So remember, when we convert zeros to factors, x equals 0, x equals 4, x equals 1 plus I square root of 2, and x equals 1 minus I square root of 2. To convert from zeros to factors is you make each of these equal to 0. So my first one here, x equals 0, is already x. This one I've got to move the 4 to the other side to give me x minus 4 as my second factor. This third one, I'll move the 1 and the I square root of 2 to the other side. So x minus 1 minus I square root of 2. And then here, x minus 1 plus I square root of 2. And that's what I'm going to have to FOIL out. Now, before I jump into anything big with this, these two pieces here we know are conjugates, which then means down here, these two factors are conjugates. And if you remember conjugates, there's a pattern that emerges. The whole reason we use conjugates is so we get a format of a squared minus b squared, and that once again comes from the conjugate a minus b and a plus b. Now, if I look at this equation right here, and I say let x minus 1 equal a, and then I squared root of 2 equal b, I can see this piece here is an a minus a b, and this piece right here is a plus b. So I don't need to do the FOILing out where I've got 6 or 9 steps. I can actually use the pattern that since these two quantities are conjugates, they follow the a minus b, a plus b pattern, I can just square a, square b, and then put a subtraction sign between the two of them. So with this piece right here, and I'm just going to distribute in this x here so I can take care of that. I know that this is going to be factored down into an a squared minus a b squared. So a, we know, is x minus 1. So I'm going to write that as x minus 1 quantity squared minus whatever my b is, I square root of 2 quantity squared. Now let's write all that out. This x minus 1 quantity squared is x squared minus 2x plus 1 when you FOIL that out. This guy right here, if I square both of these pieces, I square root of 2 quantity squared is the same thing as I squared square root of 2 squared, which really is just I squared, really just 2, a 2I squared. And you know that I squared is equal to negative 1. So this right here is really 2 times negative 1, which is negative 2. So really right here, here's the first part. X minus 1 quantity squared is that piece. Then I've got minus this I squared of 2 squared simplifies down to a negative 2. So x squared minus 4x, and then the inside x squared minus 2x. These two negatives make it positive. So I've got then plus 3. If you aren't really confident with all the squaring and conjugate stuff, you can always FOIL this out and get the same result. Last piece then is we're going to then multiply in my x squared to both terms and minus 4x to both terms, and then combine like terms. So x to the fourth minus 2x cubed plus 3x squared minus 4x cubed plus 8x squared minus a 12x, and then combining like terms, x to the fourth minus 6x cubed, combine my x squareds to be 11x squared, and then finally minus 12x. So those zeros end up creating x to the fourth minus 6x cubed plus 11x squared minus 12x. And if I wanted to, I could plug this into my calculator to confirm that my 0 and the 4 are actually two zeros. And I can see this answer makes sense because my x to the fourth is a fourth degree polynomial, and there were 4 zeros that I had.